Hey, what is up guys? Welcome to another video. In this video I'll be going through practice set 7 for the Edexcel higher specification. This is a non-calculated paper and it should take about an hour and 30 minutes to complete. So let's get straight into it. Question 1 says, simplify leaving your answers in index form. So part I says 7 to the power of 5 times 7 squared times 7. So when you have the same base numbers, you can add the exponents. So here all we really need to do is 5 plus 2 plus 1. Remember, when there's no exponent, you need to think there's a 1 there. So 5 plus 2 plus 1, that's 7 to the power of 8. And then when we have brackets like this, when we have 4 to the power of 7, and then that's raised to the power of 2, this is like multiplying the exponents. So that's going to be 4 to the power of 14. Part B says 5 to the power n times 5 cubed divided by 5 to the power 6 equals 5 to the power 4. Find the value of n. Well, on the left hand side here, remember we can add these exponents, so we'll be doing n plus 3. And then when we divide by the same base number, we subtract the exponent. So we need to do n plus 3 minus 6, and that should equal 4. So n plus 3 minus 6 equals 4. So what will n be here? Let's just go ahead and solve this. So n minus 3 equals 4, and so then n must equal 7 there. So n is 7. If you want more detail on these index laws, check out my video on index laws. I go through this in much more detail. Question 2 says, find the highest common factor of 147, 42, and 252. So for this question you need to use prime factorization. So we need to break each number into its prime factors. So let's start with 147. That could be, well, I know 3 times 50 is 150. So 3 times 49, that must be 147. Because you add one more 3 and that will be 150. So that's where I'm starting. So 3 is a prime factor, and then 49 I know is 7 squared. And that's a prime factor. 7 is a prime factor there. So that's 147. And then 42, well, that's 6 times 7. 7 is a prime factor, and then 6 is 2 times 3. Okay, and they're all prime factors. And then 252, I might just start with 2 here. 2 times 125 would be 250, so it must be 126. And so 2 is a prime factor, and then 126, that would be 63 times 2. 2 times 60 is 120, so 63 times 2 must be 126. So that's going to be 2 times 63. And then 63 I know is 7 times 9. And then 9 is 3 squared. Okay, so I've factorized those three numbers into their prime factors. And now to find the highest common factor, we need to find the prime factors that are common between all three numbers. So the common prime numbers of prime factors, let's see. We have a 3 here, and a 3 in 42, and a 3 in 252. So there's 1 3. I have a 7 in 147. 1 7 goes into 42, and 1 7 goes into 252. So my two common prime factors are 3 and 7. I can't see any more. So we can work out the highest common factor by just multiplying those together. So the highest common factor here will be 3 times 7, which is 21. Question 3 says the total weight of 3 identical video games is 525 grams. Work out the total weight of 5 of these video games. So we need to work out the weight of one video game. Because they've told us they're identical, it means they'll have identical weight. So we can divide 525 by 3 to get the weight of one game. So 3 into 5 goes once and carry the 2. 3 into 22 goes 7 times with 1 left over, and then 3 into 15 goes 5 times. So one game weighs 175 grams, and then we can multiply that by 5 to get the weight of 5 games. So 5 times 5, that's 25. Carry the 2. 7 times 5 is 35. Plus 2, that's 37. Carry the 3. 1 times 5 is 5. Plus 3, that's 8. So 5 games will weigh 875 grams. Question 4 says the perimeter of a triangle is 90 centimeters. The length of the sides of the triangles are in the ratio 3 to 5 to 7. Work out the length of the longest side of the triangle. Okay, so this is, I'd suggest drawing a diagram for questions like this, if they don't give you one. So we know the ratios are 3 to 5 to 7. We can say, therefore, this side times something will be the length. These are not the lengths, these are just the ratios. However, if we multiply those ratios by some number, what we might call the scale factor, then we'll get the actual length of the triangle. So this side would be 3 times something, this one will be 5 times something, and the longest side will be 7 times the same thing. So that's how we can turn that ratio into the actual lengths. And we know the perimeter equals 90, so we can say that 3 lots of something plus 5 lots of something plus 7 lots of something equals 90. And then, so that gives us 15 lots of x equals 90. So that scale factor must be 90 divided by 15. 15 times 2 is 30. So 90 divided by 15, that's going to be 6. So x there is 6. So therefore, the longest side will be 7 times 6. That will be 42 centimeters. Let me just give a quick example of why I can just introduce an x there. So if, let's say I had a rectangle and the lengths are 10 and 2. So what's the ratio there? It's 1 to 5. You can see there when we have a ratio, both sides are reduced by the same amount, and that will always be the case. Question 5 says there are x stamps in a small packet, x plus 3 stamps in a medium packet, and x plus 4 stamps in a large packet. The total number of stamps in the 3 packets is n. Write down an equation for n in terms of x. Give your equation in its simplest form. So we just need to add these amounts of stamps up to get n. So n is going to be x plus 3 plus x plus 4. And then we need to simplify that. So that's 3 lots of x plus 3 plus 4, that's 7. So n is going to equal 3x plus 7. Then they tell us there is a total of 61 stamps. Work out the total number of stamps in the medium packet. So they're saying n equals 61. So we can say 3x plus 7 equals 61. So then 3x equals 61 minus 7, that's 54. And then x equals 54 divided by 3, and 3 lots of 18 is 54. So x is 18. But then we still haven't answered the question because they asked us how many numbers of stamps are in the medium packet. So if we look back at the start of the question, there are x plus 3 stamps in the medium packet. So the medium packet will be 18 plus 3, which is 21 stamps. Question 6 says write 75,000 in standard form. So hopefully you know what standard form means. That means there's one number between 1 and 9 multiplied by a power of 10, which equals 75,000. So I need to divide that by 1,000 to get 7.5. So this is going to have to be 10 to the power of 4. In other words, 10,000. So 7.5 times 10,000, that equals 75,000. Then it goes on, a computer can carry out a simple calculation in 1 picosecond, where 1 picosecond equals 10 to the minus 12 seconds. Write down in standard form the time in seconds for this computer to carry out 75,000 simple calculations. So what we're looking for here is 75,000 picoseconds. That's essentially what the question is asking, and they're asking us to write that in seconds. And we know that 1 picosecond is 10 to the minus 12. So we need to take this number, multiply it by 75,000 to get the amount of seconds that this will equal. So we can take that number, 7.5 times 10 to the 4, and multiply it by 1 picosecond in seconds. So that's going to be 10 to the minus 12. So now we have base 10 numbers with exponents, so we can add those exponents. So 4 minus 12, that's minus 8. So this is going to equal 7.5 times 10 to the minus 8 seconds. Okay, so we just multiplied 75,000 by the amount of seconds in a picosecond. Question 7 says, Sally got 32 out of 80 in a maths test. She got 38% in an English test. Sally wants to know if she got a higher percentage in maths or in English. Did Sally get a higher percentage in maths or in English? You must show your working. So here we're converting 32 out of 80 into a percentage. And there's a couple ways you could do this. So the first way, we could say that 80 equals 100%. And break this down into percentages and work out 32 as a percentage. Let's say we could say that 8 must be 10% of that mark, because I've just divided both by 10. And then 32, that's 4 times 8. So we can say 32 must be 10% times 4, or 8 times 4. So 32 will equal 40%. For the test. The second way you could do this is to try to convert this fraction into a fraction out of 100. So what do we need to, how can I turn 80 into 100? Well, one way to do it is you could divide it by 4, which equals 20, and then 20 times 5 equals 100, and then we do the same with the 32. So we divide it by 4, and we get 8, and then times 8 by 5, and we get 40. So 32 out of 80 will equal 40 out of 100, which equals 40%. And then I guess we should also state our answer. So we can say Sally got a higher percentage in maths. Question 8 says the length of Emma's journey from her home to her friend's house is 72 kilometers. The journey takes 1 hour 20 minutes. Work out her average speed in kilometers per hour. So we need to work out how many kilometers in 1 hour. So we could work out how many kilometers she did in, say, 10 minutes or 1 minute, and then multiply that to get to an hour. Or we could look at this fraction, 72, and 1 hour and 20 minutes, that is the same as 80 minutes. Remember, there's 60 minutes in an hour plus 20, that'll be 80 minutes. So we can write this as 72 kilometers in 80 minutes. And then if we have a look at this fraction, we can reduce this. So 8 goes into both numbers here. So 8 goes into 72 9 times, and 8 goes into 80 10 times. So this fraction 72 out of 80 turns into 9 over 10. So this means that she did 9 kilometers in 10 minutes. So if we know she did 9 kilometers in 10 minutes, we can multiply both of those by 6, and we'll know how many she did in an hour. So 9 times 6, that's 54 kilometers, and 10 times 6, that's 60 minutes. So we just multiplied by 6 there, and so now we know that her average speed was 54 kilometers per hour. Question 9 says the mean of 6 numbers is 40. 3 of the numbers are 102, 60, and 30. Each of the remaining 3 numbers is equal to x. Find the value of x. So we need to create an equation here and then solve it. So the way we find a mean is to add all of the numbers up and then divide by how many numbers there are. So we know there are 6 numbers and we have 3 of them. So 102 plus 60 plus 30 plus the 3 other numbers, and they're all the same, so we can say that's just 3x divided by 6, and that equals 40. So we've created the equation and now we just need to go ahead and solve for x. So the first thing I do is multiply this side by 60 to get rid of this denominator here, and then add these numbers up. So if I add those up, 102 plus 60 plus 30, that's 102 plus 90, that's 192, plus 3x, and then 6 times 40 is 240, and then we can subtract 192 from the right hand side, so that's going to be 3x equals 48, and then x equals 48 divided by 3, that's going to be 16, so x equals 16. Question 10 says y varies inversely as the cube of x. Given that y equals 24 and x equals 2, find the value of x when y equals minus 3. This question is worded slightly differently, but it's basically an inverse proportion question. Usually they might say something like y is inversely proportional to the cube of x, but it still means the same thing. So we can say that y is inversely proportional to x cubed, and then to make that an equation we can say y equals k on x cubed. So we have to introduce that variable k to make it equal, and then when we're told that y equals 24 when x equals 2, we can substitute those values into this equation and solve for k. So let's go ahead and do that. 24 equals k on x cubed. 2 cubed is 8. So now k is going to equal 24 multiplied by 8. 24 multiplied by 8, let's just do a quick multiplication just to make sure we don't make any mistakes. So 4 times 8 is 32. Carry the 3. 2 times 8, that's 16. Plus 3, that's 19. So k will equal 192. And then we need to find the value of x when y equals minus 3. So again, substitute that back into the equation. So minus 3 equals, now we know k equals 192 divided by x cubed. Okay, so now we can solve for x here, so we can swap these numbers over. So x cubed equals 192 divided by minus 3. And let's do another bus stop division here. So 192 divided by 3. 3 goes into 19 6 times with 1 left over, and 3 goes into 12 4 times. So 192 divided by 3 is 64. So x cubed equals minus 64 because we have that minus there. And then we need to take the cube root of 64 of minus 64, and 4 times 4 times 4 is 64, so x must equal minus 4. Whenever you're taking the cube root of a negative, the answer will always be a negative, because think about it this way, minus 4 times minus 4 times minus 4, that's going to be 2 negatives make a positive, but then you have another negative on the end there, so that's going to make negative 64. Question 11 says ABCDE is a regular pentagon. Calculate the size in degrees of an interior angle of the pentagon. Okay, so to work out the interior angle of any polygon, you can use this formula, n minus 2 times 180 divided by n. And I've done a whole video going over this formula. I went into a fair bit of detail, so if you haven't seen this or you're not completely understanding it, check out that video. Hopefully it helps. And so n stands for the number of sides of the polygon that you're looking at. So we're looking at a pentagon with 5 sides, so we substitute 5 into this formula and we will get our interior angle. So 5 minus 2, that's 3, so we're doing 3 multiplied by 180 divided by 5. And then we get 3 times 180, that's 540 divided by 5. And then 5 goes into 500 100 times, and then 5 goes into 48 times, so this is going to be 108. So an interior angle of a pentagon is 108 degrees. The second part says the point F lies inside the pentagon such that the angle CDF equals 70 degrees and angle FEA equals 85 degrees. Okay, so CDF, that's in here, so that was 70. And FEA, that's in here, and that's 85 degrees. Okay, and part B says calculate the size in degrees of the reflex angle DFE. Okay, so reflex, that's an angle bigger than 180. So larger than 180. So let's look for angle DFE. DFE. The reason they say it's reflex is because they don't want you to look for this angle. They want you to look for the one around the outside here. So that's the angle we're looking for. And if we look at this diagram carefully, by adding this point F here, we've actually turned this pentagon into a hexagon. We now have 1, 2, 3, 4, 5, 6 sides. So we're actually looking at this shape, A, B, C, D, F, E, and we know all of the angles inside this hexagon except one. So we can work out the total of the interior angles of a hexagon using this formula. So n minus 2 times 180. That will give us the total of the angles inside a hexagon. And then we can use that number to find the missing angle DFE. So we substitute 6 into this formula now, so we'll do 4 times 180. 4 times 180, that's 720 degrees. And now we know that, well, we know all of these angles in here. This is 108, this one's 108, and this one's 108 degrees. And we know these two. So we need to add up all of those 5 angles and take them away from 720 to get F. So let's go ahead and do that. So we've got 3 lots of 108. 3 times 108 plus 70 plus 85. And so what does that equal? Let's just do a quick multiplication over here. 108 times 3, that's 4, carry the 2, 2, 3, 324, plus 70 plus 85, that's 155, and then 324 plus 155, that's going to be 479. Okay, and then if we take that away from 720, so 720 minus 479, so the difference there is 241, and that will be the missing angle DFE. So angle DFE equals 241 degrees. So what I did was I added all of these angles up, took them away from 720, which is the total of the interior angles of a hexagon, to find F. Question 12 says there are 32 students in a class. All the students are either left-handed or right-handed. The ratio of the number of left-handed students to the number of right-handed students is 1 to 7. Work out the number of right-handed students. So we have in this ratio 8 parts. So 8 parts, and the total is 32. So then we can work out 1 part by dividing those by 8. So 1 part will be 4 students, and then the right-hand students are 7 parts of this ratio. So we can say 7 times 4 will be the number of right-handed students, that's 28. So there are 28 right-handed students. Okay, the question goes on. Sajid makes a scale model of a bus. He uses a scale of 1 to 32. The length of Sajid's scale model is 45 centimeters. Chitra makes a scale model of the same bus. She uses a scale of 1 to 48. Work out the length of Chitra's model bus. Okay, for this question, we actually need to work out the length of the real bus to work out the size of Chitra's model. And the way we work out the size of the real bus is to take Sajid's scale and multiply 45 by 32. So let's go ahead and do that. 45 times 32. So 5 times 2, that's 10. Carry the 1. 4 times 2 is 8, plus 1 is 9. And then let's do the tens. 5 times 3, that's 15. Carry the 1. 4 times 3, that's 12. Plus 1, that'd be 13. And then let's add these together. So 9 plus 5 is 14. Carry the 1. 3 plus 1 is 4. And then 1. So the total size of the real bus is 1,440 centimeters. So that'll be about 14 meters. So that looks about right. And then we need to go ahead and divide that by 48 to get the size of her scale model. So you could try to do it using the bus stop method, but then you still have to work out, well, how many times does 48 go into 144? And then you're probably the best way is just to use trial and error. So 48 times what equals 144? So 48 times 3 you could try, and so 8 times 3 is 24, carry the 2, 4 times 3 is 12, plus 2, that's 14. So 48 times 3 is 144, so 48 must go into 1,440 30 times. So Chitra's scale model will be 30 centimeters. So we used this scale to find the length of the real bus, and then because her scale was 1 to 48, we had to divide the size of the real bus by 48 to get the size of her scale model, which was 30 centimeters. Question 13 says a bank pays compound interest of 1% per annum on its savings account. Evan invests $7,500 for 2 years. Calculate the total interest gained after 2 years. Okay, so remember this is a non-calculated question, so we're not going to be using the compound interest formula. Let's do it a slightly easier way. Let's just increase it by 1% and then increase it by 1% again. So if 75,000 is 100%, then we can divide that by 100 to get 1%. So 7,500 divided by 100, that's going to be 75. So 75 is 1% of 7,500. So if we increase that by 1% after 1 year, so after 1 year, we will have 7,575 pounds. And then we need to go ahead and work out 1% of that. So 1% will equal, divide that by 100, that's going to be 75.75. And then add that on to that total again. So after 2 years, we're going to have 7,575 plus 75.75, or 75 plus 75, that's 150. So we'll have 7,650.75 pounds. And then because it says in the question, calculate the total interest, we need to figure out the difference between the initial investment and the final amount. So that's going to be 150.75. Question 14 says the first 3 terms of a different Fibonacci sequence are A, B, A plus B. Part A says, show that the 6th term of this sequence is 3A plus 5B. Well, you need to know in a Fibonacci sequence, you're adding the previous 2 terms. So the first term is A, the second term is B, and the third term is the last 2 numbers added together. So the most common one you might see is 1, 1, 2, 3, 5, 8, where you're taking the first 2 numbers, adding them together to get the next one, and then the next term is 1 plus 2, and then the next term is 2 plus 3, and then the next term is 3 plus 5, etc., and it goes on. So that's what a Fibonacci sequence is. So we can say that the fourth term here will be b plus a plus b. So that's going to be a plus 2b. The fifth term will be the fourth term plus the third term, so a plus b plus a plus 2b. That's going to be 2 lots of a plus 3 lots of b. And then the sixth term will be the fourth and fifth terms added together. So that's going to be a plus 2b plus 2a plus 3b. So that's 3 lots of a plus 5 lots of b. And we've ended up with the term that they asked us to show. Okay, so the next part of this question says, given that the third term is 7 and the sixth term is 29, find the values of a and the value of b. This is going to produce a set of simultaneous equations. So the third term is 7, so we can say a plus b equals 7. And the sixth term is 29, so we can say that 3a plus 5b equals 29. And now we can go ahead and solve this. I'm going to use substitution. So I'm going to start off by rearranging this equation here to say that b equals 7 minus a. And then I'm going to substitute that into the second equation. So my next line here will be 3a plus 5 lots of 7 minus a. And this allows me to now solve this equation for a. So let's expand these brackets out. So 3a plus 35 minus 5a equals 29. And then so we get minus 2a, 3a minus 5a, that's minus 2a, equals 29 minus 35. That'll be minus 6. So a must equal 3 there. Minus 2 lots of 3 equals minus 6. And then to find b, we can substitute this value of a back into this expression, this equation. So this becomes b equals 7 minus 3. So b must equal 4. So a equals 3, b equals 4. Question 15 says the probability that Muhammad is late for school tomorrow is 0.05. Probability that Helen is late for school tomorrow is 0.15. Sam says that the probability that Muhammad and Helen will both be late for school tomorrow is 0.0075 because 0.05 multiplied by 0.15 equals 0.0075. What assumption has Sam made? This would be true. There's nothing wrong with his reasoning here, as long as these events are independent. So the assumption he's made is that the events are independent. So what I mean by that is Muhammad being late has no effect on whether Helen will be late. As long as they do not affect one another, then this would be true. But let's say Muhammad and Helen are brother and sister, and they go to school together. So if Muhammad is late, then Helen is going to wait for Muhammad, and she's going to be late as well. In that case, Muhammad being late affects Helen being late. So then this isn't true. Another example might be that they get the same bus to school maybe, and if the bus is late, then they'll both be late, and then they wouldn't be independent events. So events need to be independent to use this rule. So that's the assumption that Sam is making. Question 16 says find the value of x when 3 to the power of 2x equals 1 over 81. Okay, so what would this have to equal? Well, 3 to the power of 4, that equals 81. That's like 3 times 3 times 3 times 3. That's 81. And in order for it to be 1 over 81, this needs to be minus 4. So 3 to the minus 1, that's 1 over 3. Remember your rules about negative exponents. So 3 to the power of minus 4, that's 1 over 81. And so to make 2x equal minus 4, x must equal minus 2. Question 17 says the frequency table gives information about the lengths of time 100 people spent in a coffee shop. And part A says on the grid draw a cumulative frequency graph for your table. Okay, so we have our graph down here, and what we need to do first is to work out the cumulative frequencies. So this is adding the frequencies up as you go down the list. So the first one will just be 4, and then the next one is 4 plus 12, so that's 16. And then the next number will be 26 plus 16, that's going to be 42. And then the next one is 42 plus 42, that's 84. And then the next one is 12 plus 84, that's 96. And then the next one is 4 plus 96, that's 100. So you should always end up with the total that they tell you it should be. If you finished on 104 or 98 or something, you'd know you'd made a mistake with this adding up. But because we finished on 100, I'm pretty confident my adding up was correct. Okay, so now I have my cumulative frequencies. I can plot them on this graph. And remember that cumulative frequencies are plotted on the upper bound of this interval. So we take this cumulative frequency, 4, and we plot it at 20 on the time axis. So the first point is going to be 20 and 4. Okay, so let's go ahead and look at this scale here. We are going up in 2s, so each line on this scale is worth 2 units. So the first point was 20 and 4, so that's going to be here. The next point is 1640, so 40 on the time axis and 16 on the cumulative frequency. The next point is 60 and 42. Okay, so that's going to be here. The next one is 84 and 80. 80 on the time axis and 84 on the cumulative frequency. And the next one is 96 and 100. So 196 should be here. And then 100 and 120. So that's right in the corner here. Okay, so we've plotted the points now, and now we need to go and sketch the graph. Don't rule in the lines. I think you lose marks if you rule the lines in for these. So you actually have to sketch the curve as best you can. And I'm actually quite bad at sketching cumulative frequency graphs. And it's kind of scary because you often need to sketch the graph and then use it to answer another question. So you do have to try to be as accurate as possible because it can affect your answers in the next part of the question. So you have to kind of look at the shape of the graph and try to follow it as best you can. And there we go. That's not a bad effort for me actually. Okay, so part B says use your graph to find an estimate for the number of people who spent longer than 70 minutes in the coffee shop. Okay, so on a cumulative frequency graph, they often ask you to find estimates. So we need to find 70 minutes on the time axis, that's here. And then we need to go up to the graph, roll the line up to the graph, and then go across to the cumulative frequency and see what that time equates to on the cumulative frequency. In this, on my graph, it's about 64. And they're asking how many people spent longer than 70 minutes. So that will be this amount of people here. So this was 70 minutes or longer. And that's going to be 100 minus 64. So that'll be about 36 on my graph. I think they will have an interval of maybe about between maybe 35 to 40 perhaps. So it's okay if you go a little bit under or over 36, but just try to be as accurate as possible with sketching your curve and then you should be fine. Question 18 says n pounds is shared between 3 people in the ratio 2 to 3 to 7. The largest share is 540 pounds more than the smallest share. Calculate the value of n. Okay, so the smallest share was 2 parts, the largest share was 7 parts, so the difference between those two is 5 parts. And they've told us that The largest share is 540 pounds more than the smallest share, so 5 parts of this ratio must equal 540. What that allows us to do is to find what 1 part will equal by dividing this by 5. So 1 part will be 540 divided by 5. That's going to be 108. And then we need to work out the value of n. And so how many parts in total do we have? Well, we've got 2 plus 3 plus 7. That's 12. So 12 parts in total. And so therefore we need to multiply what 1 part is equal by 12. Okay, so 8 times 2, that's 16. Carry the 1. 1 and 1 times 2 is 2. And then let's do the tens. 8 times 1 is 8. 0 and 1. And then add these together. 6, 9, 2, 1. So the total there is 1,296 pounds. Question 19 says express the square root of 48 plus the square root of 108 in the form k root 6 where k is a surd. So initially when you're tackling problems with surds you want to simplify the surd as much as possible. So you want the highest number that goes into these numbers that is a perfect square. So 48, you need to think of the factors of 48 and one of them needs to be a square number. So 48 is 2 times 24. Neither of those is a square number. It's also 3 times 16 and 16 is a square number. So that's the highest square number that goes into 48. So I'm going to use these factors and we can use this rule that you can break surds into their factors. So if you have some surd, it can equal the square root of a times the square root of b. So just to give a concrete example, if you had the square root of 10, you could say that's the square root of 5 times the square root of 2. So that's perfectly fine to do that with surds. So we can say the square root of 48 is the square root of 16 times the square root of 3. And let's have a look at the square root of 108 now. So let's think of some factors of 108. So that's 2 times 54. And well, neither of those is a square number. It's also 3 times 36. So 3 times 30 is 90 and 3 times 6 is 18. So that makes 108. And 36 is a square number, so I'm going to use those two factors and break this surd up into the square root of 36 times the square root of 3. And so now let's have a look back at the square root of 48 again. So this will be the square root of 16 is 4, so that's going to be 4 times the square root of 3. And the square root of 108 is going to be 6. The square root of 36 is 6 times the square root of 3. So this expression now becomes 4 root 3 plus 6 root 3. As I've said, the square root of 48 is 4 root 3 and the square root of 108 is 6 root 3 in their simplest forms. And then we can add those together because they have that common element of the square root of 3. So I can add those together and I'll get 10 lots of the square root of 3. And now that's in its simplest form, but we need it with a square root of 6 in it. So how can I change this square root of 3 into a square root of 6? I can multiply it by the square root of 2. But in order to not change this expression, I need to multiply it by the square root of 2 divided by the square root of 2. So what I'm going to end up with is 10 root 3 times the square root of 2 divided by the square root of 2. So this now becomes 10 root 6 divided by the square root of 2, and then therefore that factor before the square root of 6 will be 10 on root 2. So k equals 10 on root 2. Question 20 says the histogram shows information about the time taken by cyclists to finish the cycle race, and they give us the histogram, and then it says 7 cyclists took 80 minutes or less to finish the race. Work out an estimate for the number of cyclists who took more than 95 minutes to finish the race. Okay, so they give us this information because if you look at this histogram, you notice there's no scale on the y-axis. So this bit of information here allows us to figure out what that scale is. Remember, in a frequency density histogram, the area of the bars tells you how many people belong to that interval. So they tell us that 7 cyclists took 80 minutes or less. So this bar, the area of this bar needs to be 7. So we know this length is 10. So 10 times what equals 7? Well, it's actually 0.7 times 10 equals 7. So this value here must be 0.7. So that tells us that this scale is going up by 0.1. So this value here must be 1. This is 2, etc. Okay, so now we have our scale on the y-axis, and this allows us to go ahead and find the estimate for the number of cyclists who took more than 95 minutes. To do that, we need to work out the area in these two bars. So if we look at this, well, let's firstly find 95 on the time axis. That's going to be here. And then we need to split this bar in half because we don't want the number of people above 90, we want the people above 95. And to work out the number of cyclists, we need the area of these bars. So we need the area of this one, and then plus the area of this one. So the area of this bar is going to be 5 multiplied by, now the frequency density there is 2.2. So 5 times 2.2, that's 11. So the area in this bit of the bar is 11. And then this bar will be 20 multiplied by 1.2. Which is the same as saying 1.2 times 10 times 2. So that's going to be 24. And so we have 11 people between 95 and 100 minutes and 24 people between 100 and 120 minutes. So the estimate there will be 35. The next part of the question says, explain why your answer to part I is only an estimate. Well, the reason it's only an estimate is because we had to split this bar up in half, but we don't actually know how many people were between 90 and 95 and between 95 and 100. It could have been, for this interval, it could have been all of the people were between 90 and 95, and there was only maybe one person between 95 and 100. We can't exactly split it in half like that. So the reason it's an estimate is because we can't tell from the graph the exact number between 95 and 100. Question 21 says, C is the curve with the equation y equals x squared minus 4x plus 4. L is the straight line with the equation y equals 2x minus 4. L intersects C at 2 points A and B. Calculate the exact length of AB. I've actually answered this question already in another video on grade 9 questions. So I'll just insert that clip from that video into here, or else I'll just link to that other video. Question 22 says x equals a times 10 to the power of n, where n is an integer and a is greater than or equal to the square root of 10 and less than 10. Find in standard form an expression for x squared. Give your expression as simply as possible. So let's just ignore this bit for now, and let's just look at this expression. So we know that x equals a times 10 to the power n, so x squared will just be these two things squared. So a squared times 10 to the n. Now 10 to the n squared, remember when we square something that already has an exponent, we can multiply those exponents. So this is just going to be 10 to the 2n. So x squared equals a squared times 10 to the 2n. And now the important part of this question says it needs to be in standard form. And when a number is in standard form, this part of the number needs to be between 1 and 10, less than 10. It can be 9.999, but it can't be 10. And it can be greater than or equal to 1. So that's for a number in standard form. We know that a is greater than or equal to the square root of 10 and less than 10. So if we just square a, let's say a equaled the square root of 10. If we square that, that would be 10. So we can't. So if we leave this answer as a squared times 10 to the 2n, this won't be in standard form because this part of the number will not be between 1 and 10, which is a key part of a number being in standard form. So what can we do to this expression to make sure it is in standard form? Well, if a was equal to the square root of 10, we could divide that by 10, and this would equal 1. Now a can't equal 10, but it can be just less than 10. So let's say, for the sake of argument, a did equal 10. So 10 squared, that's 100. But if we divide that by 10, this would be 10. However, a is less than 10. So if we divide a squared by 10, we will get a number between 1 and 10. Because remember, it tells us that a is just less than 10, it's not equal to 10. So we can divide this part of the expression by 10. That will make sure that a squared is between 1 and 10. So my expression now becomes x squared equals a squared divided by 10 to make sure that this is in standard form. However, if I divide this part of the expression by 10, I need to multiply it by 10 as well. So I've divided a squared by 10, so now I need to multiply by 10. So this is going to be times 2n times 10. So I haven't changed anything. All I've really done is multiplied it by 1, or 10 on 10. Okay, so, and now for this part of the expression, 10 to the 2n multiplied by 10, that can be simplified because here we have the same base numbers, and so we can add the exponents. So 10 to the power of 2n multiplied by 10 to the power of 1, that becomes 10 to the power of 2n plus 1. Just the same as if we had, let's say, x squared times x cubed, that will become x to the power of 5. All I've done is add the exponents here. So this expression now becomes x squared equals a squared divided by 10 times 10 to the 2n plus 1. So I've basically divided the a squared by 10 to make sure it's in standard form, and then added that times 10 on the end. Question 23 says A, B, C, and D are points on the circumference of a circle center 0. AC is the diameter of the circle. AC and BD intersect at E. Angle CAB equals 25 degrees. Okay, they've written that in for us. Angle DEC equals 100 degrees. Okay, they've written that as well. And they're asking us to work out the size of angle DAC. So that's in here. You must show all your working. We need to work out this angle in here, and what you're going to need for this is one of the circle theorems, and we'll get to that in a minute. But where should you start with a question like this? Well, maybe even when you start working on this question, you might not see the end, how you get to the answer, but you can already work out some other angles in this diagram just based on the information they give you. So for example, I can work out this angle because it's vertically opposite, DEC, AEB must be 100 degrees. So that's where I'm going to start. Angle AEB equals 100 degrees because they're vertically opposite. And in here, AEB, we have a triangle, and I can work out this angle, EBA, because angles in a triangle add up to 180. So 100 plus 25, that's 125. And then to add up to 180, 125 plus what equals 180? That must be 55. Okay, so I've worked out some more angles, and so let's go ahead and write that down. So angle EBA equals 55 degrees. Angles in a triangle. And the other thing you need to know is angles in a semicircle are always 90 degrees if they are subtended by the diameter. So you can see here they've told us that AC is the diameter, and this angle here, CBA, is joining the ends of the diameter, so that means that this angle is 90 degrees. That's something you need to know for GCSEs. So angles in a semicircle are always 90 degrees. So we can say angle CBA equals 90 degrees. And that's an angle in a semicircle. Okay, so, and now I can actually see the connection between the angles I'm working out and this angle DAC. Because if I can work out this angle in here, that will actually equal angle DAC. And that's another circle theorem that you need to know. So let's work out this angle CBD. Angle CBD will equal 90 minus 55. And that will equal 35 degrees, because you can see here that these two angles added together must be 90 degrees, so this one must be 35 degrees. And then we can say that angle DAC must be 35 degrees. And that circle theorem is called angles subtended by the same arc. So that theorem says that these two angles are equal, and also these two angles would be equal as well. So you can see here, let me just rub all of this out and demonstrate that a bit more clearly. So the circle theorem says that these two angles here, because they're coming from the same points on the circle, these two angles must be equal. And actually, I think I went through a proof of that in another video. I think that was another question from another exam. But that's one of the circle theorems you need to know. And so therefore we can say that DAC equals 35 degrees. And that's all of the questions in this paper. Thank you for watching. I hope you found that useful. I just want to say a quick thank you to everyone who is subscribed. I think it's almost over 2,500 subscribers now. That's really, really cool. I didn't expect ever to really have that many people following the channel. But yeah, it's really nice, and people are liking the videos, so leave a like on this one if you appreciated it. I'll be putting up papers 2 and 3 shortly, maybe in the next couple of days. And let me know what you think. If there's anything else you want me to go through, let me know in the comments. As always, I always appreciate people commenting on the videos. I love to hear from you, from people that are watching the videos, what you think. But thank you for watching, and subscribe if you want to see more content, and I'll see you in the next one. Bye for now.